Hallo Alice. Sounds like you mean. Mm. Nah, don't like to use copy sign here. step is always just adding to the W value. So if step is positive, then we add to the W value and we go to the right. So this larger than 0 means we go to the right. But if we should go to the left, then that is wrong. I meant yeah, this is kind of trivial now. It means like literally subtracting it. Which is the test that is being done here. So if this is true, then of course subtracting it means 0 is larger than that thing, and for both cases, which means that the offset is positive in both cases, which means that no, wait a minute. Sorry, the opposite. The above is false, so the offset has a different sign, simply, which means that of the trivially will be unequal. I don't even want to test it anymore. Hello, the square. Well, yeah, we zoomed in a little bit too far, but we should stop crashing, and we don't crash anymore. Okay, it's a good thing. Oh, we crash like immediately afterwards. That implement thing again. Oh, I think I know what it is. I think I know what it is. No, I don't. I thought that initialized range is not called. But what the hell is going on? I don't know what it is. Oh, wait a minute. We are at the end. So, yeah. Yeah, okay. It might be just a missing termination. It's still working the same way. Should go up though. 28, yeah. Drums, and that's correct. And now it doesn't know what to do anymore. Yeah, okay. No, it's behaving the same way actually. It's like really weird. Nobody knows what's going on here, but then yeah, okay. So there's no problem. It's working again. And the only thing I changed was filtering out the not relevant extremes, which did play a role exactly when. Let's try that again. Run. Yeah, in this case. So we have a minimum followed by a maximum followed by a minimum. And that minimum is around 0, very down here. And then I got annoyed by the fact that the debug output was talking about this extreme as a possibility. That should no longer happen. Let's see what if we have debug output at all now. Maybe not. Should add the debug output back in that case. Fitting a fourthly polynomial using these samples. Train derivative, quotient, second derivative. Set hdirection to right. Step right. Calling initialize range. Found larger is that. Yeah, just debug output is gone. That's a bit too much. So I did a rewrite, which seems to work, but the old code here did have some debug output that I want to preserve. This, for example. Here's debug output. Not sure I can still use that code exactly as is. The number of I'm no longer decreasing the number of quotient roots. If I yeah, I should probably just add new debug output. For example, this is we have 2 of them. I just print both. Let's do a debug output per case. It's case 1, we don't have anything. Yeah, sorry. I'm gonna start at case 1. Which means we don't have anything, which means that I'll just copy it anyway. I don't have to scroll up and down all the time. This is like really not other. Yeah, it is other actually. And for case 2, isn't it that one? Yeah, no, no. It's the wrong direction. Shit. Case 2. There are 2 roots, one of which is of the wrong type. Yeah, so that would be completely ignored, even in the debug output. So then they say there is only one other usable local extreme. Okay, so that's not true. What a bullshit. Blink, blink. I don't see it. I don't see it. Die out is hier notice. String. Oh, yeah. Yeah, I should probably just print the value. Like that. No. Yeah, this one. No output. No this output. What? No, it's not really jumping, I suppose. We're jumping backwards. It's calling this one. So this is the output then. Mm-hmm. Yeah, I don't need this anymore. I can just delete this. Hello, Mitchell. What's the other thing I wanted to change? Oh, I did. Should just restore that. It's a nonsensical change. I think that you lost some accuracy there. Mark local extrema correctly as being explored in a given direction. I'm not sure I feel up to that until I'm sure that the algorithm is in place. It is assures that we find the adjacent extremes. To kind of involve this, which in turn I can only test if I do that first. And also this. Ouch. I should probably move this to the bottom then. And this above here. Oh, this is not really necessary. I can do that afterwards then. It's just a speed up thingy. Do that here. So I think I need to add this, well, sort of a new test. Not really, but yeah. I already have a sigmoid which switches quite fast. So let's say I want to switch again around 80. And then maybe show from 90 to 80. And then maybe the second sigmoid. I think TP stands for toggle point. So I'm gonna need a new constant, which I'll call toggle point 2. And then we call this sigmoid 2. And then this one is around 80. And this one is then probably is correct. I just use TP2. And then I want to do the same thing as here. I just have 1 minus sigmoid times the parabola that was on the left side, plus sigmoid times the other function. So now we get something like blah blah blah, whoops, plus sigmoid 2 times, and then everything we have now. Let's pause that here as well. And here, yeah, something. Let's just start with a 0. That will be visible. At least we see what happens then. Oh, 0 is a bit low, maybe. Well, I don't care. Not right now. Click. Run. Yep. So now it's 0 on the left side. And then around 80 it switches to that parabola. This is a parabola. It looks like a straight line. And then here we switch again to the dampened sine wave. I think I want to make this one way sharper. Just switch really fast. Ten times as fast, let's say. Wait, one more thing. Let's not use 0 but 2500. Even a little bit higher would be nice. I don't know. I just start with 2500. So this sigmoid must be faster. That's probably the 3. And I said like 10 times faster. So then here we do something times 2500. And this then should be 1 minus sigmoid 2. I think the reason it stops drawing here has to do with this sharpness here. We have only a limited number of points. And it puts all the points here. But yeah, let's make it 2600 in a little bit. Yeah, I just need something with a maximum here, so another parabola or something. Then I have to tune it. Horrible. Instead of 2600, we have to do something with actually, I don't have doubles. We only have integers here. Something times x minus something times c squared x squared. I want this in the maximum to be around, say, 85. So I could do x minus 85. Let me think. Then I don't need the x, right? I don't need the x. This can be gone. Must be negative because you want to go to minus infinity. Maybe that must be a maximum, right? So something like this. And then this must definitely be higher. Let's begin with a guess 40. See how that looks like. Something went wrong. It's at 8 million here, and then bang, we go to something that's not visible anymore. Why is it so high? So 5 to the power 525. I am clueless. Yeah, I could add sliders to do it real time, but that takes half an hour to add now. I don't know, 15 minutes most, I suppose. And then we have sliders, and then I can make a wonderful thing. But hey, maybe I can do it with editing. My first thought is I have to divide this by something big. To multiply it with yeah, okay, that's not really going to work, is it? How many constants do we have? D. Is D even being used? I don't think so. Plus D times that. It is 100th minus 100th. I hope D wasn't already used. I don't think so. I don't see it being. Oh, it's being used here, man. I'm blind. Do not touch the D. How about E times make it negative. So now if x equals 85, oh, that must be minus 85. That was the reason why it exploded. I get that, yeah, okay, that was just stupid. Yeah, the 100th is probably a little bit too much. Let's make it 1/10 for now, see what happens. Still the same size. It's impossible, of course. Possible. No, I'm not getting that. Now it's if x equals minus 85, then this is 0 times whatever is 0. So they get 2640, which is not a million or whatever it is. No, absolutely makes no sense. Why is this so big? Makes no sense. Okay, I'm gonna make e vertically 0. Yeah, it just ticks at this super high value. I am shocked. Back to the basics. Remove this. This part worked. As in we go from 0 to the function that we had. Yeah, except that it doesn't really draw it anymore. And that is then because we switch so fast. So maybe I should change that as well. For now. Going back to, no, let's just use 6 then. Now I want to bring this 0 up to 2500. That should be easy. Yeah, that works. Now it's 2500. Yeah. Okay, I'm making it 26.4. To be even higher. a maximum of a parabola runs like this. Maybe we reach even 2800 seems. Yep. So now I want something that is 0 at minus 85 and 200-ish, minus 200 at minus 80 and also minus 90. That means that we need x plus 85 squared times something like I mean, there's no, I don't get it. E was super small. I mean, isn't it? Can you make it smaller? No. Hopefully that fits as an int. It's like virtually 0, so there should be no difference. It should just still look the same. What the hell? What is going on? Oh, I know. Yep, the precedence of this caret thing is not what I think it is. The precedence is very low or something. I'm not sure if I have to put a minute. The problem is it probably squares the whole thing, including the 2800. Yeah. I just want to square this, so you have to put parentheses around that square. Just like I did here. Just you have to put squares between parentheses. Okay, that was it. That was the reason. Let's go back to 1/10. So I can calculate it. Where's my calculator? Here. So I wanted that, say at 80, that would be of minus 80 then. That's 5 squared, that's 25, and I want to end up at 200. Minus 200, so that is then 200 divided by 25, which of course I can do from my head. Minus 8. Now we're getting somewhere. And then we have to connect this thing here a little bit better than the way it looks now. Which you can do by making the parabola a little bit broader, I guess. Let's do that. How do you make the thing broader? Change E. Yeah, go to 7, say. I'd expected more of that. That's pretty good. Oh, that's good. Okay, now, guess we're done then. So now we have a maximum here, and then it switches to the parabola on this part, and then hopefully you get like 2 measuring points in this part. Exactly in this part. Now to do that, I think I can just start here. Let's start at oh, no, it's not good. No, it might go to that side, because this goes down to minus infinity. Ugh. So I have to, the maximum is nice and all, but we have to make it go up again. And pretty quickly too, preferably detectable. As in, this should have been a cubic. Now it gets harder. It depends. Some days I'm feeling so bad, I'm hardly doing anything. If I wouldn't feel super sleepy, I would... I mean, I'm old, so I used to work 12 hours a day, sometimes 16. Now all I do is lay in bed. The time that I'm not laying in bed and I'm home, then I sit behind my PC, I do nothing else. How do I quickly get a cubic attached to this point? So annoying. Maybe you can set an hdirection already. So I just drop it at minus 87 and then set the hdirection to the right already. That should work. That should work right fine. Yeah, I don't have already examples that just allow me to draw a cubic, I think. I can draw Béziers curves. What the crash is this? Oh, very big numbers. My tube has failed. Two is not a number. This is not a number. Difference event data. It's not a number. No. Yeah, okay. That is just way too big. So it cannot calculate that value. We have to force it. Let's see. I do up, down. I mean, down. From the beginning. Minus 87. Current. See, current is. Highlight current is. Space. So we call it. No, I want to actually see the call. This call. This is what I want to see. So it's being called with minus 87 first. And then with minus 86. And then with minus 85, I bet. Yep. Then again with minus 85. Might as well do that directly. No. It's already detected as an a local extreme, I suppose. Extreme. Yeah, immediately. Because of this. Oh, yeah, yeah. So it wants to do the minus 85 again, but yeah, why would it? Because it just was called with that. Therefore, it immediately stops. Does the handle local extreme? With the minus 85, and then you do the find larger on that super big thing, but that doesn't really matter. Okay, quit, yes. So this now I call it with minus 86, and then we add 1 because I called here, I said small step to 1. So it's going to add 1 immediately. So you get, why is it saying minus 87? Thought I changed that. So we call it first with minus 86. And then add 1, so then we call it with minus 85. And that then wants to call it again with minus 85, but doesn't even return, because why would you call it again with minus 85? So it says, okay, we reach a maximum, and then it tries to find a minimum of the cubic fitted through the last 2 points, which is extremely inaccurate, so I don't care what it returns, but it could return plus infinity like it did, or something very big. And then we just overrule that. Now we have found a maximum, and I'm just pretending that this returned 80. And this is passed as a reference, so the W is just updated every time. And then if you override it, you have to call this again officially, although in this case it's not necessary, because the larger iterator is set to chain end anyway, and after calling this it's still chain end. But okay. And then we call it with 80 instead of 500 million. So minus 86, 85, and then next probe is minus 84. Interesting. So now it's not going to do something super big. Anyway, I'm overrunning that, I think. Okay, what the hell happens? Still not a number. Oh, I set it to 80 instead of minus 80. Even 80 is way too big. Cool. And it crashes still. You gotta be kidding me. Type critical. Critical point type is it's unequal none. Has failed. Why? The scale is not initialized. Trying to do a step with the scale size that was not initialized yet. Being cubic used. That's 1. Yeah, I don't know. The moment I add 2, it should initialize this cubic. And that's not happening. Why? No. Oh, right. Okay. Okay. I'm getting it. I'm finally getting it. We do have to start at 87. Otherwise we don't have enough points, and it requests an extra data point, and then I'm returning 80 and everything breaks out. So now this is minus 87, minus 86, minus 85, and then we have to do that. And it's not working. It looks like this point here, the derivative of this point, is still influenced by the sigmoid. So my sigmoid is not sharp enough. It's just a fact. I can change it to 30, but then the drawing doesn't happen, it seems. Or maybe now it is, I don't know. Because you're connecting very smoothly there. Oh, wait a minute. Minus 80 is halfway the sigma switch, so that is a half. So now we are for 50% influenced by that switch. I should not start at 80, sorry. I think we're switching quick enough to do, say, maybe 80, 82 or something. Not this one, let's say here-ish. I mean 7, minus 78 or something, maybe. Yeah, now it works. So now you have here the fit through 3 and 4 is this parabola here, which has 0 here. But the difference with before is that now we already found the maximum. And we are having already set an h-direction going to the right, which should enforce the algorithm to find only adjacent extremums. What is it? Extremums. No, that's a plural. Yeah, well, anyway, the next extremum, which is here. So it totally should reject jumping there, in this case. But it just jumps there, and you get an assert, unexpectedly. Now maybe that's what I need to implement. It's not even completely impossible. Oh, well. Okay, this is yeah. Stop streaming. I'll be back tomorrow.